So if you look at the June month rainfall, it was 10% below normal and it was exactly predicted by IMD. So I think we should congratulate IMD for getting it right, because remember, onset started late and there was cyclone. So after 15 days, it was pretty bad. So I thought, many of us thought that it will not able to make it made up. So they got the answer almost right. Now, those of you following this question for many years now, you know that the forecast by the dynamical model is good for the first week, not so good second week, third and fourth not so good. So question is, how come they got the average right? Now, I'll do this is just 1 month. You might think it's a fluke, but Dr. Surya gave one presentation. Sorry. Yeah. Let me see whether I don't have it. Dr. Surya gave a presentation sometime back on the 2019 monsoon, and he showed that for every month, the forecast for the monthly departure and the observation was matching quite well, not perfectly, matching quite well. So then you have to ask the question, is the model forecast poor in the third and the fourth week? How come they're getting it right? Now, he only showed 1 year, but I'm sure if he shows all the years, there'll be a problem. Some months will be very bad. So sometimes you're lucky because the first week is very good, second week is not bad. If the third and the fourth week errors cancel out, then you get the right answer. So that's what happened. Now, why I like this is because I've been following the prediction of election forecast the last 40 years now. 1980 started for India today. And you see most of the time, they get the all India forecast correctly. So they got regional all wrong, but they get the all India number looks correctly. So something like that. If you average the log over time and space, your errors can cancel out. So that is a possibility. Okay. When we go back now, I didn't put the 5th July. 5th July I just saw before I came. It is somewhere here. It'll come back up. But remember the last 1 week, there has been a decline in rainfall. Okay, now it will pick up. Let's hope it will continue. Otherwise, we're going to be in trouble. Now, why should I worry about it? I always remember the 2002 monsoon, in which June was normal, with pretty heavy rainfall in the last week of June, and then I get a break from the longest break in the last 150 years. Okay? And that caused the rainfall to be 50% below normal. Record, nobody has ever seen it. And as I told you today, we don't know why it happened. Because we look at the SST anomaly in July, there is no signal. Almost no signal. There was the El Nino, but it was developing stronger at the end of the monsoon. So this 2002 July is the biggest mystery in our understanding monthly Indian rainfall. Okay. Then it slightly recovered in August, but due to the 60-day mode, but was not enough. Ultimately, you can see the 690 millimeters, which is one of the lowest in the region past. So we are watch out for July. If July starts declining, one is in trouble. Now let's look at the 10-day forecast. I would say not as good as last time. The forecast pretty heavy rainfall in the initial portion didn't come out right. Then they underpredicted, and here they forecast by huge margin. But 5th July, they got it right. Well, not quite right, but better than this. So let's see whether it continues or not. So what you see here is, although each individual day all India rainfall forecasts are not so good, again, if we average, the positive and negative more or less cancel out. So that is the advantage of averaging on space and time. Okay, now what's happening to El Nino? According to the Meteorology website in Australia, all the models say next month, sorry, this month now, July, it's going to be, it's going to be above 1.1 degrees, all of them. Okay? So it's still warming up, it's not stabilized. And you look at September, I'm really amazed. It's all of them say around mostly 2 degrees, rather than 1 degree, mostly 2 degrees. Okay? So this El Nino is really growing. It's going to become one of the large El Ninos. So any hope that El Nino will not warm further is not going to happen. Here's the IOD. IOD also, interestingly, according to all the models, will be 1 degree by July and 1.2 by September. Okay. So I would argue that the prediction of almost normal rainfall by IMD is based on the expectation that a strong El Nino also induces warming in the Indian Ocean and also induces looks like IOD. And so they're hoping that two will balance out. Now, I want you to look at we focus a lot on Nino 3.4 and El Nino. So let's look at this year, June, as an anomaly, and 1972, which was also El Nino year, and which also was a La Nina El Nino transition, both same. So what's interesting is around the equator in the Pacific, you're almost identical. I was surprised. Hardly any difference, okay? So what the difference is here? Now this is what I'm not seeing anybody talk about. What is the role of the warm pool of the Pacific, the most important part of tropics? It's about 28 degrees setting almost everywhere, and it is where the center of the convective zone is in the world, and it controls everything. From there, all the convergence there, and it is very well. So this thing has become in 72 much cooler. Okay? It has not happened this year. I don't know why. So this was exploring what is the role of the SST in this region on the Indian market. I'm not saying anybody talk about it. And in addition, you also this part, of course, Arindam has covered in his paper, the North Pacific warming, which is similar in the two years. Okay, so only difference I see between 72, which was a serious drought year, and this year in the June SST is that this thing has cooled much further. I see no other a little bit effect this year, not much. Okay, and the question is whether July anomaly is similar to this. Now, I don't know, Bill, it won't be. I think that anomalies will change, of course, but change dramatically. So let us see. In 1 month's time, I'll project another two figures. Let's see how it flows this year and probably in July. Now, this is 1965. Okay, this is also one of the years La Nina transition, right? Yeah. Now, this is very surprising. I saw it. I remember Arindam didn't trust SST data before 1980. Okay. I also have suspicion because the pre-satellite era, SST, especially Indian region, you don't have much data, unfortunately. But I can tell you there are great people in this world who know how to average and how to do clever things. So what I found was that if you compare two different SST data sets, 1950 to 1970, they look alike. So I don't think that in spite of the lack of data, if you're very smart and you assume certain spatial patterns are not changing, okay, you get the right answer more or less. Okay, now then the question is, what is happening here? This is unexpected, very large cooling, more than 2 degrees in the Indian Ocean. And you know why? I found out there was a volcanic eruption in 1965 called Agung in Indonesia. Okay? That caused this. So that means the SST data level, it was able to capture, but I warn you, it can only capture large scale features. Small scale features like IoT, there is no problem. As Vinay pointed out, there's not enough data. But large scale features, the HAD SST or they're quite good. Okay, so this I thought was an error, but when I looked up the volcanic chart, there was a volcanic eruption at the sun. Okay? And I'm still not convinced because I had my doubt. Then I saw this interesting paper on the this is for a different purpose. They're looking at a heat content up to 700 meters in the Indian Ocean, how it's changing. Okay, because all of you know, Indian Ocean has a new feature, it's warming a lot due to global warming. There was a question to ask why is it warming so much? So in their analysis, also they got large reduction in heat storage in 65 because of the eruption. So that everything now hangs together. It's consistent. That cooling is related to aerosols in the atmosphere due to Agung. And it will go away after 2 years. So it just comes back up slowly. Now this is comparing 2 more years, 2009 and 2012, again in the list of La Nina El Nino transition years. And what surprised me was that although this was El Nino year, El Nino had not really come on in June. Okay. But still, we had a pretty bad drought in, I think, 2009, right? I think it was bad drought, yeah. So let's look at other patterns here. Indonesia is not fully warm pool, but there are some interesting patterns here, which are worth looking at, that they have impact on the monsoon. So what I'm trying to say is that we have focused a lot on ENSO, but you want to look at the overall effect on the Indian monsoon, you have to worry about all the other regions. Arindam has covered this region somewhat. Some people are talking Atlantic, but in many of these I've seen Atlantic seems to be not very interesting. Okay, there's a little warming here, but here there's nothing.
Yes.
Yes.
There seems to be a large difference on North Central Pacific.
Huh?
North Central Pacific, there seems to be a large difference between these 2 years.
You want this one?
Yeah.
Yeah.
Below it, just off.
This one?
Off of equator.
This one, right?
North Central Pacific.
Huh?
A little to the east, yeah. If you look at that and the lower one.
This one?
Yes, between these 2 years.
North
Central Pacific is very different.
What is it? I don't know.
If you compare these 2 figures.
These 2 figures, okay.
Yeah.
Yeah.
North Central Pacific is, is almost on the opposite side. I don't know whether that is an impact.
This right?
Yeah, just below.
Yeah. I don't know. I remember the one who looks at it, but tell me anything special about this region. Yeah, this is more than 2 degrees. Because 2 degrees is my upper, 1 to 2 degrees warming here. Now, IMD is putting out more and more all kinds of interesting graphs. This is the standardized index. This is P minus PP by sigma. Okay. So this is better way to show, because remember, India we have found very high rainfall here and not so high here. So you plot in millimeters per day or other things doesn't capture it. This captures better. So it shows that in the first month of the monsoon this year, there was, although a lot of rainfall in Western Ghats, it was pretty what do you call it, dry according to this index. So rainfall is well below normal here, and also in Central India, and also in Eastern India. Only this portion gained by the cyclone, and this portion gained by some systems coming across in the last few weeks. Okay? And of course, South India also did well in early part. But this portion and parts of North Carolina also are not doing well. So this is another way of showing rainfall anomaly, but standardized in terms of the mean and standard deviation. Now this is the general plot they give for June, and again you can see the same thing, but you can see this whole portion all below normal, along with the cyclone counts. Now, what is the forecast for the next 2 weeks? This is from ensemble of yes, this is ensemble of ECMWF, and I would say that they are quite similar, except that ECMWF forecast below normal right across here, which is also a little bit, but yeah, I would say they're more or less same. So I don't know how it averages. I would say this average is almost normal condition. Part of Rajasthan is showing low, but this portion is supposed to be high. Then I think this is a little higher. So ECMWF is predicting a slightly weaker first half of July compared to here. We'll see next week or week after how this goes. Now, one of the questions I was looking at, remember that if you look at all the years from which you got El Nino, the La Nina El Nino transition is only 6 years out of 144. Now it bothered me why it's so small. It's so small because there's one example here. It is not the year covered in original paper. This is 2005 was the La Nina, and 2006 not in the or our seat in JDS, but later on it became El Nino. So I didn't count that because during the monsoon period it did not become El Nino. So what is that you are expecting from December to June in 6 months' time, temperature to warm by 1 degree. Okay. Now that's not easy. Ocean has got a lot of inertia, doesn't easily warm up. So only certain conditions allow you to go from La Nina to El Nino. Most of the time goes from down to neutral, neutral to El Nino over a 2-year period. Occasionally, there's a new thing happen, but I have not seen anyone discuss it. Have you seen it? Why these 6 years, El Nino went to London so rapidly? What is the particular mechanism? I don't know. So that is the question to ask. Now, if you ask why, it depends on atmosphere. Okay, here's a nice paper I saw in which they compared how from El Nino, La Nino to El Nino went without atmospheric additional forcing. Then when there are 2 westerly wind bursts or 4 westerly wind bursts or 2 easterly wind bursts. So these are the ones which influence how the transfer occurs. Okay, so clearly showing that without any wind burst, you get this kind of simulation. With wind burst, it can develop more rapidly. And if there is a wind burst in the opposite direction from the east, it will not warm at all. Okay? So this transition depends very much on the atmospheric condition, that is the storms and cyclones and so on, which form over the Pacific Ocean. They are, as far as you're concerned, totally random. We cannot predict in advance. So that's why what it means is that in those 6 years that are in the recognized rapid transition within a matter of 6 months or years, for some reason, something happened due to a wind burst, which increased the chances of El Nino forming. So that is the conclusion from this paper. Now let's look at the forecast for the coming 10 days. Looks very good. I hope it's true. So average should be around 8 to 9 millimeter per day in July, and they're saying something like, well, about 50% high. So I doubt it, but let us say I hope it is right. Okay? I will know next week whether this prediction came out right, because this comes out right to me. Half the July is over. So if we got 50% above normal, even if it weakens in the second half, we'll get normal July. Okay? If we get normal July, that's a big step forward because we already have 150 millimeters rainfall in June. And if July is normal, it'll be around 290. We'll get 450, which is very, what you call, secure situation. So unless something terrible happens in August, September, we'll make it to normal. But the question we still have to ask is, in spite of a strong El Nino, if this monsoon is going normal, is it going normal because of IOD? We don't know. IOD, we will see. I still doubt whether IOD will really develop because there is no signal in the Eastern Indian Ocean. Nothing. Western Indian Ocean is anyway warm due to global warming. So that is going to help us to get more water vapor. But the key thing to accelerate is the Eastern Indian Ocean. That is not happened. But in the next 1 month, it might develop. I don't know. I don't know exact mechanism which easterlies come and cause upwelling. I have not seen any discussion on that. So that we'll see next week. Okay, now I'll just stop here, which we already discussed. So this one, we remember, we discussed what should I be in this model, NCMWF. And this looks very close to what I showed for GFS and for ECMWF. That is a little thing here and little high here. So this also ultimately come out with normal July. Let's see. Okay, any question? So that was next week. Next week, yeah. We will talk about El Nino and non-El Nino, right?
Yeah, I think PMC is super.
Yeah.
Like myself.
Yeah. Okay. Thanks.